we go. So if you see that there's three triangles, you are likely drawn to the one that's got two of the given sides. I don't know if that makes sense or not. The one with 3 and 3√3. I'm sort of drawn to that, but I will say that since it wants you to find A, well, first, that maybe we should be doing something else. So this is, I guess there's two places you could go with this. One is you were probably doing sort of this, there's the small triangle, the medium triangle, and then the large triangle.
Yes, right.
Right. So to find B, you don't need any of that. You could just use like Pythagorean theorem. But to find A, we have to be a little more creative. So let me just set this off to the side for the moment. So when I look at A, the A is really two things. It's in the medium triangle, and I like to make a table here, and it's the long leg of the medium triangle.
Right.
Okay. And it's always a proportion. Now, if you were in class, I don't know if you had like long leg over here, you put your triangles up here. I always make a table. So this other side, the 3 squared 3, it's part of the medium triangle, but it's the short leg.
Right.
Okay, and then what you're looking for is like, well, is there another triangle, in this case, the small triangle, that we know the long leg of the small triangle? It looks like it's 3√3. And then do we know the short leg of the small triangle?
3. Right.
Yeah, and see how I kind of set up this table? It's a proportion, but it's really referencing the table.
Yes.
And that's my approach to setting these up. I know they give you formulas like AB, BC, stuff like that, but this I feel is more clear because of that.
Right. Okay.
Okay, so now there's only one variable to solve for, and that's A. So we cross multiply here. So we have 3A equals 3√3 times 3√3.
Okay.
So on the right here, you multiply the whole numbers 9 times the square root of 9, which is really 3, and it's 9 times 3 is 27. Divide both sides by 3, and A is 9.
Got it.
Okay, so that's the first one. That's A, 9. To find A times B, you could just find B. Now, I guess we should do it in the spirit of the small, medium, large triangle thing. So we'll do that, I guess. Sometimes like it's not really the best way to do things, but we'll do that. So B, what is B? Well, it's the hypotenuse of the small triangle. Okay.
Okay.
And it's like, well, what else do we know about the small triangle? We know the short leg and the long leg. But if we go to the medium triangle, like if we're like, all right, let's go medium triangle, do we know the hypotenuse of the medium triangle?
No.
No. So that's not good because you don't want to have two variables in here. If you have two variables, they better be the same. So let's go to the large triangle. What do we know about the large triangle? Do we know its hypotenuse? Do we know 3 plus A?
Yes.
We do. It's 12. So what else do we know about the large triangle? We don't know the short leg, but we know it's B, and it's okay if we use that because they can match. Then it's the question is, well, do we know the small triangle short leg?
Is it also 12?
Short leg of the small triangle. So that's this one here.
Just 3?
Just 3. Yeah. Is that setup okay?
Yes.
All right. So now what's nice is, again, there's only one variable. Okay, so you've got b squared equals 36. So b equals 6.
Right.
Okay, so now to find a times b, I guess we don't do that. We know that a is 9. A times b is 9 times 6, which is 54.
Okay.
Any questions on that?
No.
All right. So now, to find c, we should again just do it in the same spirit of this sort of small, medium, large triangle. What do you see c as? Kind of where do you it's either a triangle, or it's either the size of a triangle, or it's the one of the sides of the triangle. Like, what do you visualize c as being?
The hypotenuse of the medium triangle.
Okay. So what we really hope for is that we know another hypotenuse. And we know it, like I've say, like the small triangle and the large triangle. So we actually could go either way there. When you get down to the last one, if you know everything, you're pretty much done. So are you drawn more to the small triangle or the large triangle?
The small one.
Okay, so the small triangle hypotenuse is b. We know that b is
9.
6.
Oh, sorry.
6, I think. And then what else do we know from the medium triangle and the small triangle? And it's either a short leg or a long leg. Any of those drawn to any of those?
The short leg.
Short leg. Okay. So in the medium triangle, the short leg appears to be the 3√3.
Okay.
What's the short leg of the small triangle?
3.
3. Okay, so not great, but I mean, you can definitely solve this. Do you want to give this one a try, please?
Okay. Is it, I know you have to simplify more after, but is it 3c equals 18 root 18?
√3. So you only multiply the outside number, because the √3, there's almost like a parentheses there, an impenetrable. It's underneath the root, so it's like kind of protected.
Okay. So then c equals 6 root 3.
Yes. Okay, so now you can find a plus b plus c.
Okay. Um, 18 root 3.
So you cannot combine, you can only combine things that have, like, think of the √3 as like an x. If this were 15 plus 6x, you could not combine them. So these are separate.
Okay, got it.
Okay, so just a couple things I noticed there. So let's just say I gave you a problem like this. 2 times 3 plus 4 square root 3 plus 5 square root 3 minus 4. Could you simplify this for me, please?
Yes. Is it 2 plus 3 root 3?
Is that your final answer? Sorry.
Oh wait, no. 2 plus 13 root 3.
Okay, this looks pretty good. So it's 6 plus 8 root 3 plus 5 root 3 minus 4. And yes, that is correct. Okay, so you said going on to number 7.
Yes, please.
Proof. Okay. All right. I might have to look in your book to see what they're emphasizing in this section, but we can start out with obviously the given here. So the given is that SY is an altitude. SY is an altitude. So what that means in the picture is that this angle is 90 degrees.
Right.
And so is, I mean, if we needed to, so is that one. Like they're both 90-degree angles. And we do have to say that, like we can't just like know that. We have to say now the measure, or we have to say angle XYS, angle VYS are right angles.
Okay.
And the reason is definition. It's always definition of altitude. The altitude always hits its base at a right angle. And it's, it's not a great reference, but if you, jump, well, no, never mind. Sorry, I should just know when to stop. So XY times SV equals XS times YS. Now they're also, interestingly, they're also telling you that VSX is a right angle, which I'm not sure why they're doing that, but they are. So I mean, this is the thing we've been using in the previous problems. Like I'm tempted to go towards Pythagorean theorem with this, like basically saying that VS squared plus SX squared equals XV squared, and then you doing a bunch of algebra with the other ones. But this is where I think I want to go to your book. Do you remember anything from class that might have been relevant here?
Yeah, he did an example and it was like he did like he made wait, sorry. I'm trying to figure out like how to say it. He like made the he rotated the little triangle to match the big triangle, and then he did the angle similarity theorem.
Oh, really?
Yeah.
Okay. That's cool. So we're talking about, let me do it in green here. So we're talking about taking this little triangle here and then basically rotating it so that it's in here.
Yes.
Okay. I mean, that does work. What section chapter are you in?
9.3.
9.3. Okay. Just looking at it's if an altitude, this is theorem 68 on page 378, the top, it says if an altitude is drawn to the hypotenuse of a right triangle, which is what we just said, then the two triangles formed are similar to the given triangle. So basically from this, that's the, let me snip this in so try and understand what I'm referring to.
Okay.
So if an altitude is drawn to the hypotenuse of a right triangle, so that, I mean, that's essentially what we have here. We have CD, or this one's CD, but you have SY. So since that's there, the two triangles formed are similar to the given right triangle and to each other. And that's essentially what we have here. We can say that all three triangles, the ADC is the medium one, ACB is the big one, and CDB is the little one. They are all similar. And when they're similar, you can build this proportion. So that's what we're going to say next. We're going to say that we've just got to get the letter ordering right. Sorry, I'm just trying to get this. We can still see the picture. There it is, kind of. Okay. So we want to say now that triangle, and we got to do the right order. So let's start with the okay, so let me do it this way. Let's go VSX. Okay, so here's what I did with the big triangle. I started from the long leg towards the 90-degree.
Right.
Okay, so for the medium one is VYS, but you're going to start at the long leg towards the 90 degrees. So this one's VYS.
Okay.
And the order matters here. And then the last one here is the small triangle, but you start at the long leg, the end of the long leg towards the 90-degree SYX.
Okay.
And that's the theorem 68. It's the, if an altitude is drawn, it's this wording down here. If an altitude is drawn to the hypotenuse of a right triangle, then you get all this stuff.
Okay.
How do you normally refer to that when you're, doesn't really have a name?
Yeah, no, I don't know.
All right. Well, so the nice thing is now that the triangles are congruent, you can build any proportion you want, but sometimes it's good to go to that proof step. So what we want is X. Sorry, I'm just running out of room here on this. We want, and this is really 5, we want XY times SV to equal XS times YS. So we have to build a proportion from those ones. And it's like we just have to figure out how to go backwards, like XS is in which triangle? It's in this one. I don't want to do this. YS like that. And then SV, YV. SV, XY. So you almost like go backwards. And then, so how did I do that? I was looking for ones that could go together. So it's a little clumsy, right? It's like we know XS and YS are opposite, or you just pick one of them to be opposite or diagonal. That's fine. But then it's like, well, where does the XY go? Well, XY either goes with XS or it goes with YS. And I guess it could go with either. So I guess it doesn't matter. Anyway, so once you get this here, like your reason is the definition of theorem 68. It's like the part of theorem 68 that says the two sides are proportional. And I don't know how you refer to that. So it's like 3 is the theorem. Maybe it's the contrapositive of the theorem, or the converse of the theorem, sorry. And then it's by the definition of triangles being, maybe we should say it that way, definition of similar triangles. And then the last part here is just multiplication or simplify.
Okay.
Do you typically redo the proofs in class? The ones that you got for homework?
Yes.
Okay, so you always got to check on this.
Okay.
Anything else? Any other comments on that or thoughts?
No.
Okay, did you say 9 also?
No. 11 and 12.
11, okay. Thank goodness. All right,
Yeah.
11 here. So 11's not bad, actually. These proofs are always overwhelming, but these aren't too bad. So they want you to find the area of this sector. They want you to find the area of the pizza slice, okay? And you may have a formula in your book, but you do know the area of a circle. The area of a circle is pi r squared, like that, which is great. Problem is, this is not the whole circle, right? The whole circle is if you go all the way around, and you're not going all the way around.
Right.
So how much are you going around? How much of the circle are you going around when it's 90 degrees?
A quarter.
Quarter. So you're going around the angle divided by 360 pi r squared, which it's still a quarter, but you don't have to necessarily do it. You don't have to do it. You don't have to know that it's a quarter. You can just use this formula. And notice if you go all the way around, 360 over 360 is 1, and you get back to the previous formula here. So it's 90 over 360 pi times 10 squared. So go ahead and simplify that and give me the exact answer, which will have a pi in it.
Okay. Point or 1/4 pi times 100.
Okay, can you simplify that further?
0.25 pi times 100.
Okay, you can combine these numbers. The order, like if I asked you 4 times 5 times 6, you can do 4 times 6 times 5. You can switch the order and you still get the right answer. So you want to take a quarter of 100, 25 pi.
Okay.
Any questions on that?
No, thank you.
Okay. All right, so now you can do this for any circle. So let me give you another one here to try, if you don't mind. Sorry, this is not to scale. Let's go 120 degrees, and let's tell you it's got a radius of 3 here. Can you find the area of this sector SAT?
Yes. Is it 2.7 pi?
Okay, I think you're close here. So it's 120 out of 360 pi r squared. Is that what you have?
Yes.
And the value of r is 3. 3 squared is
9.
9. So we got 120 over 360. So without a calculator, those cancel. 12 divided by 36 is 1/3. Pi times 9. You want to revise your answer slightly?
Um, is
1/3 of 9.
just 3?
Just 3. So this is 3 pi. Okay. So we've got plenty of time here. So let's do one more, if you don't mind. Let's say it's a 45-degree and the radius is 4.
Okay.
So the area of this pizza slice here.
Is it 2 pi?
2 pi. Sounds pretty good. So it's 45 over 360 pi times 4 squared. So the challenge here is, well, what's 45 over 360? Well, if you got a calculator, you just punch it in. But you can think of, what is 90 over 360? Because they're kind of related. 90 over 360 is a fourth. And since 45 is half of 90, this ends up being an eighth. Pi times 16, which is 2 pi. Good. All right, let's jump to the question 11, 12. 12, is that it?
Yes.
Okay, very good. All right, so let me snip in the picture of the circle and we'll go line by line on this. All right, so here we go. They will first ask you to find the coordinates of point C. That's part A, point C. So point C is on a circle, the radius always extends, it's always the same in any direction. So what is the radius of the circle? It's the distance from the center out.
Is it 12?
Yes. So, I mean, we're going to talk about this on the, oh, and by the way, you guys I'm going to add you to one more SAT AST class this weekend. This is one of those like free response type things. Like sometimes it's just the number that's given. You don't have to overthink some of these if you're not sure. Now, how does that help you find point C? Well, you have to know that you're going down C units.
Right.
Okay. And if you're going down 12, what's the ordered pair to get you to point C?
0, -12.
Yes.
Okay.
All right. So that's part. What would, I know it doesn't ask for it, but what would D be if they asked for that?
-12, 0.
Yes. All right. So let's go from here. Sorry, part B. Part B, find the measure of the arc from A to B to C. So that the order matters. It's truly, it's like a path. It's like telling someone, all right, we're gonna go start at A, we're gonna go around this way and go all the way down around here. What's the angle measure of that if you want to take a guess at that? What's the angle measure to go?
Is it 270?
Yes. So it's 90, 90, and 90. Good. Let's see what I asked for. Okay. So the next one, it's kind of related to what we were just doing. And the wording is very important. So it asks for the length of arc ABC. Basically, like how long is the distance, or what's the distance to walk around here? So you know that the circumference is 2 pi r, or pi times diameter, right?
Right.
But if you want sort of the sector circumference, it's the angle out of 360 2 pi r. Now you might see this slightly differently in your books, but I like this formula because it's very similar to what you've already been doing. Okay. So your angle, that's why you found the angle in part B. Your angle is 270. Your radius we talked about is 12. So I want you to try simplifying this for me, please.
Okay. Is it 6 pi?
Sounds pretty reasonable. Let's take a look here. So 270 over 360, 2 times pi times 12. So the 27 or 360, that's the hardest part here. Those cancel out, and then it's 3/4 times, and we'll just take the 2 times the 12, so that's 24 pi. It's better to divide before multiplying. So really close here. It is 6, but you have to multiply by that 3, 18 pi.
Okay.
So you're really close, really close.
Okay.
Okay, so if you don't have anything else, let's do a few more practice problems on these. That's okay with you?
Yes, all right.
So let's take a look here. Let's say I give you a circle and I tell you that this is 60 degrees, not to scale. That's horrible. Just pretend that's 60 degrees. And let's say the radius is let's say the radius is 18. Okay. I want you to find the arc length, basically the length from A to B here. Okay, so again, you're going to use this circumference sector formula. It's the angle out of 360 times 2 pi r.
Okay.
So I believe this one works out nicely, so give this a try. And if you have any questions, of course, let me know.
Right. Is it 6 pi?
I believe that is correct. Yes, it's 60 over 360 times 2 pi times 18. 60 over 360, that's 1/6. 2 times 18 is the 36. You put the pi there. Yeah, it's 6 pi. Now, these are supposed to have units, by the way, like your textbook that seems to omit those for whatever reason. But they really are. They really are supposed to have numerical values or units of measure with them. Like when you walk a certain distance, you're like, oh, I walked, 6 pi miles, even though that's weird, but you always give a unit of measure. Same with area when we were doing area earlier. All right. Do you want me to give you a few more of these? Do you want something else to work on? What would be best to help you?
Maybe more of these, please.
Okay. So we're gonna do two things for this one. We're gonna find the sector area and then the arc length. So it's really two things. It's the area of the sector and then the length, the length from A to B. So if you need formulas, let me know, but give these a try and see what you come up with.
For the first one, it's pi r squared, right?
It's the angle out of 360 pi r squared. Yeah. And the other one is the angle out of 360 2 pi r. And these are different. You may not see it this way in class, but I would encourage you to use these because these are, I think, very clear.
Okay.
Obviously, I'm biased.
Um, 64 pi and 8 pi.
So this time we're going to add some units. So it's inches squared
Oh.
for the area. And then you said 8 pi for the length.
Yes.
Inches. Okay, so let's take a look here. So 90 out of 360 pi times 16 squared. So 16 squared, that's a big one. That's 256. And then it's a quarter of that with the pi. So that looks good. Okay. This one is same thing, 90 out of 360, which is a quarter times 2 times pi times 16. So quarter of 32 is that right there. Very good. All right. We can stop a little early or we can keep going. Up to you.
Stop, please.
Okay. All right. Let me just do a quick clean up here. Stop recording.